do it for the Zoom. So make sure you get any makeup work done that you don't have done yet this weekend. Single displacement, double displacement, reactions lab, double displacement lab, all of that stuff. Hopefully you had a chance or an ability to watch this video. I'm going to try it in here. Sometimes this works, sometimes it doesn't. But basically, this is a song. It's kind of cool.
Mole is an animal that burrows in the ground, or a spot on your chin that you gotta shave around. But there's another kind of mole of interest to me. That's the kind of mole they use in chemistry. A mole is a unit, or have you heard, containing 6 times 10 to the 23rd. That's the 6th with 23 zeros at the end. Much too big a number to comprehend. Now say you had a mole of pennies to distribute round the world. Give to each of the 5 billion grown-ups, boys and girls. There wouldn't be a single soul down and out of luck, 'cause everybody in the world would get $1 trillion. Or say,
so a mole of pennies would give every single person in the world $1 trillion. So that just tells you how large of a number this is. So if you want if you don't comprehend, like a mole is just like a dozen, it's just so much bigger. If you don't understand that, that's definitely a great video to watch and get just an idea. In reality, a mole of anything other than something the size of particles like atoms and molecules, it would just overtake everything. It would be too much of that one thing. Anything that's macro, anything that we could hold in our hand and see, if you had a mole of that, it would just be out of control. So watch that video if you're still not quite clear. If we take a look, today we want to do the practice problems. I'm going to do several problems. The answers to page 6, 7, and 8 are found here. So after I do these problems, if you want to try a few of those practice ones before you submit your homework, that's what I would suggest. And then the homework quiz is 6 problems. So let's take a quick look at that. So it's the same thing. Calculate the number of moles of 84.24 grams of sodium nitride. Keep in mind, this homework is a little bit hard because look what it has. It says sodium nitride. So you've got to know how to write out the formula for sodium nitride. What's the charge of sodium?
+2.
Not +2, sodium. +1 has been said in the room. +1. How about the charge for nitrogen? Larry Kaufman. I'm playing. Charge of nitrogen? Nobody wants to play the nitrogen charge game. Well, it's on this side, so it's negative. How many away from neon is it? No, nitrogen. One, 2, 3, right? So it's -3. So how many positive ones do we need to balance out a -3? Nice. That would be 3. So the formula for sodium nitride would be Na3N. So when you do that then, 22.99 times 3 plus 14.01.
It's 82.98.
That's how you find the molar mass of that sodium nitride. So we're taking and we're bringing in other ideas that we've studied in the past, that naming thing and being able to figure out a formula. We're merging that with this at this point. So just keep in mind that that's where we're headed. Yeah, right, Seth. 3. Good. So that's the mole homework. Here's me working some practice problems if you don't get enough today during the time. Now, here's the cool thing. Like I said, this weekend is catch-up weekend because Monday is whenever I want that mole homework submitted. So I'm also going to give you time on Monday. you should have more than enough time this weekend and today and Monday to get a lot of work done that you're missing. Monday also, we're going to discuss percent by mass because Tuesday is a no-in Zoom day because of the election day. If you are 18, please go out there and vote. If you take a look, we'll do the notes section for the percent by mass on Monday, and then you'll be able to revisit the lesson of percent by mass on Tuesday on your own. There's a video me discussing it again, as well as Tyler DeWitt discussing it. And here are some notes over the topic. So there we go. All right, without further ado, I think you can look at the next week. It's jam-packed with some awesome stuff. Unfortunately, we don't have a lab until the following week over this unit. So let's go ahead and go to me working some practice problems out. So just for fun, I'll sit here, and I know it has it on there already, but let's take a look. It says nitrogen trichloride. So that is, since it says tri, that means we're using prefixes for the number of things. We have one N because there's no prefix, and trichloride means that it's Cl3. Right? So we want to find the molecules of that. We want to find molecules of nitrogen trichloride. They give us a number. So we start with that 75.5 moles. Since we have moles on top, I want moles to be underneath so they cancel. Every 1 mole is how many molecules? Since it says molecules, that's a particle. So that is Avogadro's number. So type that into our calculator. 75.5 times 6.02 times 10 to the 23rd. If it's on top, we multiply. If it's on bottom, we divide. I don't need to ever multiply or divide by 1 because x times 1 is x. Remember, the number that goes with moles is always 1 whenever it's in the conversion factor. And the number that goes with particles, like molecules, atoms, or formula units, is Avogadro's number. 3 significant digits here. We have 5.5 or 4.55 times 10 to the 25th molecules. Easy enough. Now, if instead of molecules or atoms or formula units, it says grams, that means we use the periodic table of elements. This is iodine. Iodine is diatomic. So I take 126.90 and multiply that by 2. 126.90 times 2.
That would be 253.8.
Since that's how many grams it is, there are 253.8 grams from the periodic table in every 1 mole. 22.5 divided by 253.8.
The answer is about 0.08865.
3 significant digits, 3 significant digits. That's moles of I2. The last type of problem has you doing 2 things: formula units and grams. Remember, I don't have to think as long as I keep the unit lined up so that it cancels. So this is 2.06 times 10 to the 23rd formula units. That means formula units has to go down here. Well, every time I'm doing one of these conversions, the other thing I'm converting is to moles or from moles. So 1 mole at the top. What number goes down here? Well, does that say grams? Because if that says grams, I'm getting that number off the periodic table. It doesn't, so that means it must be Avogadro's number. I have mole here, so that means moles has to go down here to cancel. How many moles? Well, it's always 1 moles. I want grams. So if I want grams, I have to go to the periodic table. 1 Na, 1 Br, and 4 oxygens. 22.99 plus 4 times 16 plus 79.90.
It's 166.89.
Right? 22.99 plus 79.90 plus 4 times 16. Now we use the calculator. 2.06 times 10 to the 23rd divided by 6.02 times 10 to the 23rd times, since that's on bottom, we divide. Since this is on top, we multiply. 166.89. It gives me 57.1. 57.1 grams. $57.1 grams. Questions? All right. So if that wasn't enough practice, by all means, if you have questions, pop back on to the Zoom. Otherwise, like I said before, the answers to all of these practice problems are here. And if you're still having trouble with bridging this counting thing and stuff like that, obviously take a look at this video here. Or don't forget the actual homework assignment itself has me working out some of those problems. There's another 4 or 5 minutes of me working out some of these practice problems. Have a great weekend. Happy Halloween.